Welcome back to the lecture series on microeconomics. Last time we have discussed first welfare theorem, and now we are going to continue our discussion on the violations of the assumptions that we make to have a perfectly competitive market working and their implications. We will start our discussions with the case of unit tax imposed by a government. So, what is a unit tax? So, this is basically a fixed amount that is charged by government, of course, per unit of commodity sold in the market. So, now we are going to write a simple mathematical model to find the implications of imposition of unit tax on a particular commodity. So, we are going to write these equations. So, QD is basically quantity demanded, and that is basically a function of the price that buyers pay. So, that is basically my equation number A. Then quantity supply is basically a function of the price that seller receives, and that is denoted by PS. That is my equation number B, and of course, we know to find market equilibrium we need to have QS equal to QD, market demand shall meet market supply at the equilibrium price, and that equilibrium condition gives me my equation C in the model. And there is another equation, a fourth one, which is basically the difference between this price that buyers pay and sellers receive, and that is basically the amount of unit tax imposed by the government. That is basically my equation number D. So, when we solve this system of equations, we get market solution. Now, we are going to show that that solution is suboptimal because it generates deadweight loss, or it gives rise to deadweight loss. Before we draw a graph and show deadweight loss in this case, let us think how to approach to solve this model mathematically. Now, we can take two different approaches. We can either shift the demand function or we can shift the supply function. Let us first think about the supply side of the story. So, we will first start with the competitive firm. So, a competitive firm has a profit maximization problem. There we know how to proceed the revenue. So, the profit is equal to revenue minus the cost of production minus the tax that the firm should pay, right. So, this is basically the T, which is the unit tax rate. Okay. So, we know what to do, we need to take derivative of this profit function to maximize profit, and that derivative shall be with respect to quantity, because that is what the firm decides. So, the firm gets P minus C prime Q minus T, and we need to set that to 0. And what is the implication of this first order condition? We get price equals to marginal cost plus T. So, that is basically the result that is going to be critical in this case. So, the star is basically the first order condition that the firm needs to satisfy in the case of a unit tax imposition. Now, note at this MC component. So, MC is basically a part of MC is basically the supply function of the firm, and as T is a positive number. So, that means that if the government imposes a unit tax on the commodity that this perfectly competitive firm sells, then the supply function shifts upward to the left, and the difference between the initial supply curve and the new supply curve after tax imposition gives the rate of the tax. So, if I want to draw a diagram, so this is small q, a particular firm's output level in competitive market, and price and MC that I plot along the vertical axis and T as well. So, in that case, if we start with some initial supply function, I assume this to be a straight line marginal cost curve without loss of any generality. So, this is basically individual firm's supply function, right. So, if there is a case of unit tax, this supply function shall shift up. So, the supply curve shall shift leftward, and this broken line gives me the changed supply function, which can be denoted by S prime, and that is exactly equal to MC plus T, where T is the unit tax. So, this difference that we observe here is basically the unit tax rate that is imposed by the government. So, this is exactly what is happening to a particular firm. Now, let us get into the deeper details of the supply side of the story. So, if a particular competitive firm's supply function shifts left, shifts upward, then the horizontal sum of all competitive firm supply shall give rise to a new industry supply or aggregate supply function, and that new aggregate supply function, which is after tax imposition, shall also shift upward, I mean leftward from the original location of the supply function, and this is due to the imposition of the tax. So, one approach to model the implication of unit tax imposition is by shifting the market supply function or the aggregate supply function in the traditional competitive market demand supply diagram. So, now I am going to plot that conventional competitive equilibrium, conventional perfectly competitive market diagram, where we have capital Q as the market quantity bought and sold, and price, market price measured along the axis. And suppose we start with the demand function, a straight line downward sloping function, without loss of any generality. Let me call this DD. Okay. Now, let us impose the supply function, and let me impose the supply function which is also a straight line, and this is market supply original, So, that is basically before tax. Let me write this down. So, this is before tax, and let me also write down here the same thing, so that later we do not get confused. So, this is D before, right. So, the initial equilibrium, the perfectly competitive equilibrium is to be obtained at the intersection point, we all know that, and the equilibrium market price and quantity are determined, say capital Q star is the perfectly competitive equilibrium output level and P star is the perfectly competitive price, right. Now, if there is unit tax T imposed, then there will be a shift in the supply function, and the supply aggregate supply function S shall shift upward, and that can be given by this blue broken line, and I call this S prime S prime. So, this is my supply function after the tax. Okay. Now, a new equilibrium will be obtained at the intersection of this new supply function and the original demand function dd. Of course, there will be some quantity that will clear the market, it implies that demand shall be equal to supply, and let that quantity level be Q double star, right. So, when in a perfectly competitive market the aggregate supply function or the market supply function shifts upward, then what does that mean? That means that the buyer has to pay now extra price, right. So, there is a difference between the price that the buyer actually pays and the equilibrium market price. So, then we observe what buyers actually pay inclusive of tax, okay. And then there is a difference between what buyers pay and what is the equilibrium price. Now, we can analyze the case of unit tax imposition from the demand side as well, and in that case we have to shift the demand function, but here remember never shift both the demand and supply functions. So, either you shift the demand function or you shift the supply function to analyze the implication of unit tax imposition on a commodity. Okay. So, now let us study the demand side of the story. So, now in the case of demand side, we are going to study how it is going to impact the demand function of the market, right. So, if government imposes some T dollars of tax, then basically we have to shift the demand function parallelly downwards, and we can draw that shifted demand function through this broken brown straight line, and we call it d prime to denote the after demand function. So, let me write after here, right. Okay. So, in the second case where we have shifted the demand function in response to the imposition of unit tax, what we observe? We get the price that sellers actually receive net of tax. Now, let us go back to our diagram and let us analyze. So, in this case also we see that there will be an equilibrium of course to be obtained at the intersection between the original supply function S s, because we have not shifted that curve, we have only shifted the demand function. So, the intersection will be now between S s curve and the d prime curve, and a new market price will be obtained. Note that the way we have drawn the equilibrium quantity level is basically same in both the cases, because we are talking about the parallel shift of the demand function or the supply function by the same magnitude, right, and the magnitude is basically the tax rate T. So, although in the diagram it may not look to be same, but please note that the difference between the broken line and the solid line is basically fixed constant, and that is basically the rate of unit tax. Okay. So, now let us see that actually there are, although the quantity bought and sold in the market is same in two treatments that we have given to this simple model, but the prices actually are different. So, here in the first case, when we have shifted the supply function, we get the price P b, which is basically higher than the equilibrium price P star, that is basically the buyer's price, right. So, if you note our equation A here, we have already specified this demand function as a function of buyer's price or price that buyers face after tax imposition, and in the second case where we have shifted the demand function down and kept the supply function intact, there we observe a lower price, market price, which is given or denoted by say P s, and that is basically we call seller's price, or the price that sellers receive net of tax, and earlier in our mathematical model we have assumed that our supply is a function of P s, right. Okay. Okay. So, here we see that there is a difference between the price that buyers pay in first approach and the price what sellers receive in the second approach, and I want to draw your attention to the difference of these two prices. The difference between P b and P s is exactly the amount of tax that the government imposes on one unit of the particular commodity, which is basically given by our equation D in our mathematical model. So, here I would like to draw your attention to this particular equation, which says that the difference between P b and P s, so P b and P s is basically T, right. Fine. Now, a very interesting question that comes to mind is this. So, when government imposes rupee 1 or $1 tax on a particular commodity, how the price is going to react to that? Do we see $1 or 1 rupee increase in the market price of the commodity, or the question can also be, another question can be asked, that if a 1 rupee or $1 tax is imposed on a commodity, who will take the burden of that tax? So, who will pay that tax? Is it going to fall upon the shoulder of the buyers, or is it going to be borne by the suppliers or the sellers? Now, we are going to study mathematically to find answers to these sort of interesting questions. So, now we are going to enter this area what is known as incidence of a tax. Let me be very clear here, we are going to discuss a very simple case. The incidence of tax can be really complicated in real life, where we work with nonlinear demand and supply and complicated market structures, but here let us assume that we deal with a very simple model. Okay. So, what do we mean by incidence of unit tax? So, let me define that. So, this actually means how much of the tax will be borne by buyers and how much will be borne by sellers. So, let us study the graph first. So, from graph the consumers or buyers, the burden let me note the origin here O. So, OPB minus OP star, right. Okay. And let us now find out the burden on producer or seller, and that would be equal to OP star minus OPS, right, and that is basically the distance P star PS, and similarly we can see from the graph that the consumer's burden would be P star PB, right. So, this is what we observe from the graph. Now, can we find some mathematical formula which can talk about the exact distribution of this tax burden on the consumers and the producer? Because a graph is a graph, right. So, if you draw the demand function and the supply function with different slopes and intercept, you may get different PB, PS and P star values, and of course, these graphical magnitudes will vary from one graph to the other. Hence, some mathematical treatment is required to find the incidence of tax on the consumers and the producers in a robust manner. So, now let us assume that Q is basically my pre-tax quantity bought and sold in the market, and then of course dq is basically the change that is observed post tax imposition. Okay. Similarly, we can assume P to be the pre-tax market price, hence dP is basically change in the market price post tax, right. Okay. So, now I would like to draw your attention to one formula that we have used earlier, we have introduced earlier, and that is basically the concept of demand elasticity or price elasticity of demand, right. So, if we adopt that formula, we can from that if we rearrange the formula, then we get this. Right. And as we know that generally demand elasticity is negative, so we have to work with the absolute value and then it is perfect. Similarly, we can use another concept which have been introduced before, and that is the elasticity of supply. And if we rearrange the formula for elasticity of supply, then basically we get elasticity of supply. Well, I can write this D here to denote demand, that will be more straightforward. Okay. Okay, now let us get back to the formula for elasticity of supply. We have elasticity of supply times change in producer's price divided by the market price, right. Okay. So, from these two I can also write okay. So, one can write dpp dps es divided by ed, right. We know that T is basically our per unit tax. When it is imposed in the market by government, will be shared between the buyers and the sellers. So, we can write T equals TB plus TS, where TB is basically buyers tax share or tax incidence, and TS is basically seller's tax incidence. Now, note that this TS can be rewritten as negative change in the producer's price, and similarly the buyer's tax incidence can be rewritten as TB equals the change in the buyer's price, right. So, if we mark this expression by say star from and this expression by double star, combining star and double star. So, we have to utilize this fact and that fact into to rewrite the expression given by star, and then we can actually write TB divided by TS shall be equal to elasticity of supply divided by the elasticity of demand's absolute value, right. Okay. Now we can write T minus Ts. So we can now focus on this tax incidence on the buyers. Note that by utilizing this expression double star for this TB element, one can write TB as T minus Ts, and then this will become so we can from here we can write T divided by Ts equals Es divided by Ed plus 1. So we get Es plus Ed divided by Ed, right. So now note that this is interesting because it says something more, and we can look at that thing when we take inverse of this. So let us rewrite Ts divided by T, and that will give Ed divided by Es plus mod value of Ed, right.